Welcome everyone to BBS Station, and I hope you're having a great day. Today we have some people in a factory, and they'll be doing an interview about material. What material is that? Just you wait. Are you excited for it?
Quite, yes.
Yeah. Me too. So on site we have Cristofer, our correspondent, and he'll be interviewing people in the factory and asking what the mysterious material is and what its property are, what its properties are. Oh my, I'm so excited! And it's amazing because it shows just how much we've progressed in these past few years. It's just filled with wonder. So, without further ado, I hope you enjoy the interview.
Hi guys, we're on site now and we want to interview the technicians of the factory now. Halo Pak, perkenalan dulu namanya siapa?
Chandra, Pak.
Chandra. Oke Pak Chandra, bisa jelaskan apa itu Masterbatch?
Masterbatch itu pewarna untuk produk jadi, Pak.
Oke. Dan bagaimana Masterbatch diintegrasikan ke dalam plastik?
Diintegrasikan dia bahan campuran ke bahan PK lalu buat diproduksi.
Oke. Dan jenis plastik apa yang digunakan di sini?
Jenis plastik PPPK.
PPPK. Oke. Produk apa saja yang dibuat di sini?
Produk ya macam-macam, ada basin segi, Teko Eskandora, Mukyupe dan semacamnya.
Oke. Bagaimana proses kerja cetakan injeksi?
Ya proses pekerjaannya ya cukup mudah, kita hanya manasin mesin sama setengah jam, nah kemudian bisa langsung proses.
Oke. Berapa lama waktu yang dibutuhkan mesin untuk tetap menyala di sini?
Setengah jam mungkin manasin dan 12 jam kita produksi.
Oh, cepat juga ya Pak. Jika ada produk gagal yang akan dibuat, apakah produk tersebut didaur ulang?
Ya itu produk itu didaur ulang dan kita cetak kembali.
Oke, makasih Pak. Oke, back to you, Eshana, Valdes.
Thank you so much to our correspondent on site, Cristofer. Now, for those of you who have seen the video, we were on site too. So, Valdes, how was the experience?
It was quite wonderful, actually. There were a lot of things that I found fascinating, from the machines, their process. And when I was there, I was thinking to myself, how does this actually work?
Yes. How is this, and how's any of this practical? But in fact, which might surprise you, was that we saw a recycling machine over there.
Yeah.
So, plastic that doesn't get used, they would recycle it, and all of the different machines where ready-made stuff just comes and it just pops out. It's really amazing.
It is.
All right then, next on to our in-house scientists, Jovin and Kevin, who will be telling you a little bit more about the process.
Thank you, Ishna and Valdes, for introducing us. So, first thing first, what is Masterbatch? Masterbatch is a solid or liquid additive that is used for coloring a polymer composition. It is a highly concentrated mixture of pigments and other components and is normally added before or during extrusion of the polymer composition to obtain a colored polymer. So here's an example of a pigment Masterbatch formula. In this picture, R1 is an alkyl group comprising 1 to 20 carbon atoms, and Z is a hydrogen. Now I would like to talk some of the disadvantage of the pigment master batch. In practice, for coloring different polymer composition, different pigment master batch must be prepared. Also, coloring with pigment master batch can give the problem of non-uniform color distribution in the extrudate. Another problem is the change from one master batch to a different master batch on processing equipment. During this change, cleaning of equipment is necessary, and cleaning of the equipment tends to take hours of time, which is a problem to most factories as they will stop on production.
Then, when we want to make master batch, of course, there should be preparation. And going through it one by one is one, blending molten Fischer-Tropsch wax, and with one or more non-wax polymers, and one or more additives, such as calcium carbonate, titanium, and pigment, with fiber also added into the blend. Note that the wax has to be a consistent melting point and has to be modified functionally natural, a specialty, or a blend of them. While in comparison, the non-polymer has to have a substantially higher melting point than the wax and has to be a certain form when blending. 2. We need to temper this blend, or in other words, cooling the blend to just above the congealing point. And how, you may ask? Well, that moves on to number three, solidifying the blend by normal cooling and dispensing the blend onto a cooled surface that is a chilled dimpled roller surface, where dimpled sized pellets will be formed when the blend solidifies. Those dimples are then milled and grounded to form fine particles of the blend used in the master batch. Once formed, the blend is then comminuted, where the process is carried out at normal atmospheric conditions and temperatures below 100 Celsius to achieve a low shear process. What, what you should have in said master batch is fiber dispersed among the master batch, including at least 40% titanium dioxide, but with a preferable 80% titanium dioxide, with both polymer and wax having a 1 to 99% mass of the blend. That's all. Back to you, Valdes and Ishna.
Thank you, Kevin and Jovin, for that kind explanation. I understand quite a bit. Sure, there are some bits that I don't comprehend. My mind's not that clear these days. But all in all, it's actually quite an amazing process. I really do wonder how humanity was able to discover such a thing in the first place. What's your opinion on this?
People were bored, and then the boredom led to science, and then the science has led to tests. So some discoveries should have been made, but that is besides the point.
Sure, yeah.
Right then, thank you so much for the explanation, and thank you to you guys for listening and coming along with us. It has been a pleasure. Signing out is your host, Ishna, and
Follow this.
thanks for watching.
Toodaloo.